Hello, welcome to the final project for ISM 6021. My name is Christopher Pasgiata, and I'll be presenting with Daniel Brown, Michael Fazzino, and William Parker. We'll be talking about geographical information systems, and we'll begin with an overview, followed by relevant components of GIS, and the cost, benefits, as well as risk, while finishing up with the future trends for geographical information systems. First and foremost, I'd like to begin with an overview of GIS. So, what is geographical information systems? Well, it's a framework for gathering, managing, and analyzing data. GIS integrates many information into visualizations using maps and 3D scenes. With the unique capability of GIS, it reveals insights into data such as patterns, relationships, and situations, helping users make smarter decisions. Furthermore, what is geographical information systems used for? You know, Hundreds of thousands of organizations in virtually every field are using geographical information systems to make maps that communicate, perform analysis, share information, and solve complex problems around the world. Ultimately, I would say GIS is changing the way the world works. So, how does geographical information systems work? Well, it's advanced technology, and GIS technology applies geographic science with tools for understanding and collaborating. It helps people reach a common goal. This common goal is to gain actionable intelligence from all types of data.
GIS uses 5 key components, and these are hardware, software, data, people, and methods. We'll go further into each of the component in the following slides. GIS hardware is the most important component. This could be a setup with desktops, laptops, notebooks, tablets, mainframes, or servers. The most hardcore GIS analysts will use dual monitors with whatever setup they're using because the amount of multitasking that's required by GIS applications. However, in any single setup, you will want to have high requirements for the CPU, the RAM, the GPU, and the hard disk drive because that is what makes everything work. The CPU is the headquarters for processing data. It stands for Central Processing Unit, and it's basically the workhorse for the whole GIS application. The RAM is the best place to store frequently used data. It's where data is temporarily stored, and GIS analysts use large amounts of data. You want to be able to access it quickly, so that is why the RAM is utilized. The GPU is what displays the graphics on the computer screen, so you will want to have high requirements because GIS work with very detailed maps and a large amount of data displayed on the maps. So a low GPU power is not going to effectively display what the analyst needs to see. Hard disk drives are used to transfer large blocks of data. The more space you have, the better because GIS analysts work with huge amounts of data. Geographic information systems would not be possible without the software. So let's see exactly what the software does. It provides the functions and tools needed to store, analyze, and display geographic information. And this is done through key software components. Tools for the input and manipulation of geographic information, a database management system, tools that support geographic query, analysis, and visualization, and a GUI for easy access to tools. All of this sounds pretty technical, but people probably don't even realize that they've already used GIS software before. And this could be Google Maps. And some of the tools that Google Maps features is an input, say, of an address, and you find where that address is on the map. And you can even search for other things like restaurants near me. So that is an example of a simple GIS software. However, there's many professional ones offered by, say, Esri, which is ArcGIS, and there's also Maptitude, which is very in-depth and used for multiple different reasons. Now we will cover GIS data. As we have learned, data is one of the most important aspects to making business decisions. A professional can collect their own data by doing surveys, or they can purchase it from a commercial data provider. Three of the top providers for GIS are Natural Earth Data, Esri Open Data, and USGS Earth Explorer. Each offers a variety of different set of data. Natural Earth covers culture, physical, and raster base map data. Esri has 67,000 open data sets from many organizations worldwide, and USGS Earth Explorer gives you access to one of the largest databases of satellite and aerial imagery. The fourth GIS component is people, and this could be a wide range of users that range from technical specialists who design and maintain the system to those who use it to help them perform everyday work. So, it takes a lot of effort to become a GIS analyst and to master the skills that are needed to effectively use GIS applications. There's currently 10 universities that offer GIS programs to help people gain the technical skills for GIS. Samples of those universities: Arizona State University, University of Florida, and Pennsylvania State University. Once people have mastered the GIS skills and become GIS analysts, there are many different methods that they can use to effectively achieve the goals that they're seeking. Successful GIS operates according to a well-designed plan and business rules, which are the models and operating practices unique to each organization. So sample methods could be: find the best site locations, use aerial and satellite images for geographic editing and reference, locate your customers and your facilities, determine market potential and target growth opportunities, and analyze real estate trends. These are just a sample, and many professionals will create their own methods for achieving their business results.
When it comes to companies deciding on whether or not to go with geographical informational systems, they tend to decide on going with GIS using a benefit cost analysis. For companies, the costs begin with the price to implement, and these costs usually include the cost of hardware, software, transformation of maps and data into digital format, and adding or training of staff, versus the benefits of GIS implementation, which usually account for either greater efficiencies or effectiveness. Overall benefits of using geographical information systems include not only being able to visualize the data, but also being able to save time and money, more accurate location information, unlimited amount of data, and quicker response to failures. Visualizing data is as simple as being able to take a spreadsheet that gives you longitudes and latitudes of cities versus being able to visualize on a map where those cities are actually located. Saving time and money, the benefits come from the software that is included with geographical information systems. This software allows you to reduce costs and improve the quality of the information needed in order to make decisions, not just financial decisions as far as for the economics of the business, but business decisions as well. With the more accurate location information, this is especially important for companies such as utility companies who are looking at locating buried assets such as water pipes or cables. The unlimited amount of data. The unlimited amount of data is just the magnitude of all the data that can be transferred from physical type data into digital format. And as far as quicker response to failures, this data or this aspect of the benefits of GIS allows for, if we were to add a tracking device onto, or a GPS device onto assets, this allows for the ability to be routed to any situation that is experiencing failures by the fact that you know exactly where these assets are and the easiest route for them to get to the failure locations. When it comes into recognizing the risk of using geographical information systems, we really come across a small handful of risks. Some of those risks include the lack of training or qualified staff that may be a result of implementing this. Another risk could be the difficulty in converting some data or information into digital format. And a third risk that we see often is the being able to understand the scale of information or misunderstand the results provided by a geographical information systems. As the technology has improved and the current methodologies that go into geographical information systems, we do see a decrease in these risks. But as far as on the scale of information, these are still very apparent. A prime example of this would be if you were to take data from a satellite image and merge it with data from a street level image. It could cause your results or the information that you're using to make a decision to not be as accurate as you would like. However, these days using GIS is more so for risk assessment, and you see this with a lot of companies, such as with hazard mappings, threat mappings, and even in insurance underwriting.
There are 5 main future trends for GIS that will have implications for years to come in the world. With location as a service, services-based GIS has allowed GIS professionals to connect with clients through web-based applications. Customers can use GIS to see what a location or layout would look like, painting an accurate picture for the user's eyes, leading to the next 4 topics, which are advanced analytics, big data analytics, real-time GIS, and mobility. Spatial analysis uses vast amounts of data to help a business owner, for instance, determine where to open a new location and how, using any connected device at any moment in time. It is easier and faster to upload or input data to begin analysis immediately, even outside of the traditional office. These are our references. Thank you.